by range. Now since the trajectories are identical, means range will same, angle theta will same. We say then we can write G proportional to U square, and from that we can solve. So for the Earth, let us consider it is GE, and for other planet GP, then GP by GE, that is equal to UP square by UE square, means initial speed of the projectile at planet P and initial speed of the projectile at Earth. Then on the Earth, initial velocity of projection is given 5, and on the other planet it is 3. So then it will be 3 square, that is 9, and this one will be 5 square, that is 25. Now GP will be, G means given 9.8 into 9 by 25. Calculate GP. It is slightly greater than 3, that is 3.5. Okay. Next, a particle is moving such that its position coordinates xy at 2,3 meter 2,3 at time t equal to 0, 6,7 at time t equal to 2 seconds, and 13,14 at t equal to 5 seconds. You have to find the average velocity between 0 to 5 seconds. See, average velocity means total displacement by total time. So V average, it will be final x coordinate minus initial x coordinate, that is 13 minus 2, that is 11 I cap. Then final y coordinate minus initial y coordinate, that is 14 minus 3, that is also 11 j cap, divided by time interval 0 to 5 seconds, 5. So the answer is 11 by 5 I cap plus j cap. Next question. See, no need to solve the detailed question. For the next one, you have to only find out the acceleration of the system. Okay. Now you can see that this mass is m1, suppose. This mass m2. There is another mass m3. Now when you consider the entire system as a whole, then tension is behaving as an internal force. For all the entire system, tension is the internal force. So only external force is gravity and friction. So on this mass there is m1g, and on these two mass there are friction forces acting. Say F2, F3. Okay. Then along the line of motion, what is the net force? Along the line of acceleration, the net force is m1g minus mu into m2 plus m3 into g, because F2 is mu m2g, F3 is mu m3g. So these are the friction forces which opposes the motion. So this net force will along the line is m1g minus those friction forces. Okay, because tension is internal force, because we consider entire system as a whole. Then this is the net force. Then net force by total mass of the system. Total mass of the system is m1 plus m2 plus m3. That will be the acceleration. Okay. Then all are given m. So this one is mg, this one is mu into 2mg. So taking m common, you can write g minus, taking mg common, we can write 1 minus 2 mu divided by 3m. So this is the answer. G into 1 minus 2 mu by 3. Because m1, m2, m3 all are given equal m. So option 3 is correct. Okay, question number 5. The force F acting on a particle of mass m is indicated by the force time graph shown below. The change in momentum of the particle over the time interval from 0 to 8 seconds. You have to calculate the area under force time graph to calculate the change in momentum. That is impulse. Now see that area above the time axis is taken with sign positive, and area below the time axis is taken with sign negative. So then you have to calculate the algebraic sum. Means with sign. So first one, area is a triangle, so it will be positive and it will become half into base into height. So base is 2, height is 6. So this first term positive, then next one negative, that is 2 into 3. Then next one is again on the upper side, so it is positive, that is 4 to 8, that is 4 into 3. So this will give you the total change in momentum. So this is 6 minus 6 plus 12. So answer is 12 Newton second. Okay. Next, a balloon of mass m descending down with an acceleration a, where a is less than g. How much mass to be removed from it so that it starts moving up with an acceleration? This is a question from Newton's law of motion. First, the balloon is descending with acceleration a. So in that case, let us consider mass of the balloon given. So weight is acting on it and buoyant force is acting. So in this situation, if you write Newton's law, you will get mg minus b equal to ma. In the next situation, some mass is dropped from the balloon. Since mass is dropped from the balloon, now the mass of the balloon changes. But since it is a small mass, volume will not change by an appreciable amount. As a result, we can write buoyant force is still same, but weight changes. Weight becomes m minus small m, suppose. So this small m should be dropped into g. Now it is accelerating up. Then b minus m minus m into g, this is now equal to ma. M minus m into a. Okay. Now you have to eliminate buoyancy. So add these two equations. Then just multiply and write mg minus capital M plus small mg equal to ma plus ma minus ma. So mg cancel. So it will be m common, g plus a equal to 2ma. And from that you can find small m. Small m equal to 2ma by g2. By g plus a. Option 1. Okay. Next, question number 7. A body of mass 4m is laying in xy plane at rest. It suddenly explodes into 3 pieces. 2 pieces of mass n moves perpendicular to each other with equal speed v. The total kinetic energy generated due to explosion. That you have to calculate. See. This is the body. So it is fragmented. So 2 pieces are going perpendicular to each other. So it has a velocity mv. Momentum mv. Its momentum is also mv. So remaining mass is 2m. So suppose that 2m is moving along this direction for maintaining the conservation of linear momentum. So let us consider 2m's velocity is v1. Okay. Means resultant of these two and this one will be equal and opposite. So this two resultant will be root over of 2mv. So root 2mv must be equal to 2mv1 such that momentum is conserved. So from this equation we can write 2mv1 equal to root 2mv. M cancels, so p1 equal to v by root 2. v1 equal to then v by root 2. Then we have to calculate the total kinetic energy generated due to explosion. Since before explosion there is no kinetic energy, so final kinetic energy is the energy generated due to explosion. So that is for these two masses, half m v1 v square plus half m v square plus half that mass is 2m and its velocity is v1 square. V1 square means x square. So v square by 2. Calculate. So it is 3 by 2 mv square. Okay. Next, the oscillation of a body on a smooth horizontal surface is represented by the equation. Equation is given for SHM. The displacement time and frequency of the oscillation. See, x is given a cos omega t. X equal to a cos omega t. Now we know that in case of SHM, acceleration equal to minus omega square x. So it will be minus omega square a cos omega t. So this part is a constant. And remember there is a minus sign. So x cos omega t. So x versus t. This graph will be like this. Cosine function. Then it will only bear a minus sign. So if you multiply with minus, then graph will start like this. So this is a versus t graph. Because cos theta's graph starts at 0, it will be plus 1. So there is a minus sign. So it will be minus cos theta. So at 0 the value will be minus 1, starting from minus 1. So option 3 is correct. 9. A solid cylinder of mass 50 kg and radius 0.5 meter is free to rotate about its horizontal axis. The massless string is wound round the cylinder with one end attached to it and other hangs freely. The tension in the string required to produce an angular acceleration of 2 revolutions per second required. See, we know that tau equal to I alpha. Then tension is producing the torque, so T into R will be equal to I alpha. Cylinder is free to rotate about its horizontal axis. Means moment of inertia of the cylinder is half mr square. T into R equal to half mr square alpha. Then you have to calculate tension. So this one you have to calculate half. Mass is given 50 kg, R is given 0.5, and alpha is given 2 revolution per second square. So you have to convert it to radius per second square. So 2 into 2 pi. Next, question number 10. The ratio of acceleration of a solid sphere rolling down an incline of angle theta without slipping and slipping down the incline without rolling. See, when it rolls, AR, that is equal to G sin theta by 1 plus K square by R square. And when it slips, it will be simply g sin theta, and k is the radius of gyration. Now you have to find out the ratio of rolling without slipping and slipping down the incline without rolling, their ratio. That means R by AS, that ratio is asked. So g sin theta will be cancelled, so it will be 1 by 1 plus k square by r square. Solid sphere moment of inertia is 2 by 5 mr square. Two by 5 mr square about center, about the diameter. Where you have to take about which point? About the point of contact. Next question is also very easy. Question number 11. A black hole is an object whose gravitational field is so strong that even light cannot escape from it. To what approximate radius would Earth have to be compressed to be a black hole? See, escape velocity from the Earth's surface is dE equal to root over of 2 gm by r. Okay, then if it is black hole, then this escape velocity should be greater than c. So I will put c and calculate the value. Then it will be root over of 2 gm by r. Then find the value of r. So that is r will be 2 gm by c square. So if radius of the Earth is this, then it will become a black hole.
Sir, can we put the value of small g sir there to calculate? Why sir?
Because if you put the value of small g here, you want to put,
Yes.
that is g r square, but in that case acceleration from the surface will be now 9.8. If you calculate small g into r square, let's check. 2g no, because it shows that it's a very large radius. That is not possible. Why it is not possible? Because when you change this one, then gm is not equal to gr square anymore, because you compress the earth already. Okay, that's why you cannot apply that formula. You have to apply through this, because this g is now variable. You cannot consider it to be a constant. So use this formula to find it. Because as r changes, g will vary. Okay, next one is dependence of intensity of gravitational field on Earth with distance from the center. See, if I put only the magnitude of gravitational acceleration g variation, then option 2 is correct. But here they consider that the earth is producing the attractive field, so just option 1 is correct. If you put the magnitude only, then option 2, that is normally given in the book, they considered with negative sign, that is producing attractive field. So the option 1, just invert of 2, is the correct answer. Then question number 13. Copper optics volume V is drawn into wire of length L, when the wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? See, y equal to F by A divided by delta L by L. Now we know that volume V equal to AL. So in place of A, I will substitute V by L because volume is given constant. So we can write y equal to F by A into small l by delta L. F by A divided by into small l by delta L. Now, y can be written as, but by substituting this one, A will be changed to V by L. So F by V into L square delta L. So we can write delta L equal to F by YV into L square. Now this entire term is constant. Constant force is given, so F is constant, Y is constant for the a single drop of radius R means the surface area decreases. Surface area decreases means surface energy will be released. Surface area decreases means energy will be released. Now, there are two options of energy release. One is there for release and 3 is there. So we have to find out which one is correct. See, when all such drop coalesces to form, then we know that R equal to n to the power 1/3 small r. R equal to n to the power 1/3 small r. Then energy released in this process delta E will be 4 pi r square into surface tension into n to the power 1/3 minus 1. We calculate the change in area. Change in area will be 4 pi r square into n to the power 1/3 minus 1. Okay, that into T means change in area into surface tension will give you surface energy released. Then multiply with 1 r. So it will be n to the power 1/3 by r minus 1 by r. Okay, multiply 1 r outside and then 1 by r inside. Then multiply here with 3, another 3. So it will be 3 into volume of the bigger drop into T, n to the power 1/3 by r means small r. So option 3 is correct. See here for the calculation we use that area is increased on one side because it is droplet, not bubble. If it is bubble, then this term will be 8. Bubble or soft film, then that term will be 8. Since it is droplet, there will be no such 2. Free surface on one side. Next, 14. Steam at 100 degrees Celsius is passed into 20 gram of water at 10 degrees Celsius. When water acquires a temperature of 80 degrees Celsius, the mass of the water present will be C. In this case, some steam is condensed to water. So the amount of steam that is condensed to water, let us consider its mass is N. Then NL means the latent heat absorbed by that part of, latent heat rejected by that part of the steam to condense to water at 100 degrees Celsius. Then this one will be converted to 80 degrees Celsius. From 100, when first it releases the latent heat, it will come to water at 100 degrees Celsius. Then final temperature is 80. So it will reduce its temperature from 100 to 80. So some sensible heat has to be rejected. And then this entire loss in energy will be equal to the gain in energy by the water, which is initially at 10 degrees Celsius. Okay. So water at 10 degrees Celsius have a mass, suppose M1. Then it is specific capacity of water into delta T1, suppose. So this delta T is 100 minus 80, and then delta T1 is 80 minus 10, that is 70. Different. Remember that. That's why I write delta T1. So calculate that small m. So it is m into 540 plus n into specific capacity 1 in CGS. Then this is 20 degrees Celsius. Okay. Then for this one, mass is 20 gram. C is 1, that is 70. Increasing temperature from 10 to 80. Then calculate small m first. M equal to 0 cancels calculate. So N equal to 2.5 gram. So this water will mix with the initial volume mass of water. So final mass of water will be 20 plus 2.5. That is 22.5 gram. 22.5 gram. Okay. See, question number 16. Certain quantity of water cools from 70 degrees Celsius to 60 degrees Celsius in the first 5 minutes and to 54 degrees Celsius in next 5 minutes. The temperature of the surrounding is. You have to use Newton's law of cooling. That is T1 minus T2 by 2 equal to some constant K into T1 plus T2 by 2 minus surrounding temperature Ts. Then substitute and calculate. Sorry, this one is T2. See, first cools from 70 to 60. So this is 70, this is 60, so 70 minus 60, 10 in 5 minutes equal to K into that one, 70 plus 60 by 2, that is 65 minus Ts. So this is 2, this is my first equation. For the next equation, it goes from 60 to 54. So that is T1 is 60, T2 is 54. So 60 minus 54 means 6 by 5. That is coming K into now 60 to 54 means 57 average minus Ts, that is 2. Then divide these two to eliminate K and find Ts. So if you do 1 by 2, then it will be 2 by 6 by 5. 2 by 6 by 5 means 10 by 6. This is equal to 65 minus Ts by 57 minus Ts. Then multiply and calculate Ts. Ts equal to 45 degrees Celsius. Okay. Next, monatomic gas at temperature P, at pressure P and having volume V expands isothermally to a volume 2V. So when it expands isothermally, then volume will be 2V, then pressure will be P by 2. So finally we consider the steps as P1 V1, P2 V2, then P3 V3. So P1 is given PV, then it changes to P by 2 to V. Then finally this one we have to find out. So this one is adiabatic process. So we can write P2 P3 V3 to the power gamma equal to P2 V2 to the power gamma. The last transition is adiabatic. This transition is isothermal. This transition is adiabatic. Then P3, that we have to find out. It is equal to P2 into V2 by V3 to the power gamma. Then it is said that we already calculated V2. V2 is 2V. P3 equal to P2. P2 means P by 2. Now V2 is 2V and V3 is given 16V to the power gamma. Since it is monoatomic, gamma is 5 by 3. Then V will cancel. This is 2, 8. So it is P by 2 into 1 by 2 to the power 5. It means 2 to the power 3, 2 to the power 3 into 5 by 3. So it is 2 to the power 5. That means 2 to the power 6 will come, 2 to the power 6 will be 64. So it is P by 64. Question number 18. No need to calculate anything. You can find that when you calculate the lower portion of the area, the arrowheads are in clockwise sense. For the upper portion of the area, arrowheads are in anti-clockwise sense. So one area is positive, other area is equal and negative. So total area will be 0. So what done is the area under the curve, which is 0. Next one is also a theoretical question. It is from the direct formula that mean free path of the molecules of the gas. It is inversely proportional to the diameter square, so it is also inversely proportional to the radius square. Next one. If N1, N2, N3 are the fundamental frequency of the three segments into which a string is divided, the original fundamental frequency of the string given by. The option 1 is correct. How? String is divided into three segments. So let us consider this. We consider 3 segments like this. So we consider the length of the segments are not same. It is L1, it is L2, it is L3. Okay. So in the first 3 segments with and this part's frequency is N1, this part's frequency N2, this part's frequency N3. We know that N equal to 1 by 2L root T by L, means N is proportional to 1 by L. So from this we can write N1 equal to some constant K by L1, N2 equal to some constant K by L2, N3 equal to some constant K by L3. Right? Now, if it is the total string vibrating, then N proportion should be equal to that constant K by total length. Then we know that L equal to L1 plus L2 plus L3. That is the total length of the string. So just substitute N is Kn, K by N. L1 is K by N1, L2 is K by N2 plus K by N3. Eliminate K from both sides and it will be option 1. So 1 by N equal to 1 by N1 plus 1 by N2 plus 1 by N3. The number of possible natural oscillations of a column in a pipe closed at one end of length 85 cm whose frequency lies below 1250 Hz is. First calculate the fundamental frequency of this pipe. Fundamental frequency of this pipe N is V by 4L. It is V by 4L. Then V is 340 meter per second. And this one will be 340. So I will multiply to 0. So it will be centimeter per second. And then it will be 85 centimeter. 4 into 85. So the answer will be Hertz. Because centimeter will cancel, answer will be Hertz. So it will be 85, 75. Hertz. Okay, fundamental frequency is coming 100 Hertz. Then what are present? 100, then 300, then 500, 700, then 900, 00. Next one is 1300. Not possible, because in the question it is asked which frequencies are less than 1250. So 1, 2, 3, 4, 5, 6. Is there any other method to solve? Here we calculate first the fundamental frequency, then we know that 1 is to 3 is to 5 is to 7, only odd harmonics are present. So I write the odd harmonics and which are below 1250 Hz. Is there any other way to solve? There is a way to solve. We consider that some nth harmonic have frequency n. It can be written as 2n plus 1 into d by 4n. 2n plus 1 into d by 4n. Okay. Then put f equal to 1 to 50. It is 2n plus 1 and put the value of v. 340 into 100 by 4 into 85. Okay. So it will be it will be 100. So from this we can write 2n plus 1 equal to 12.5. Okay. 2n plus 1 equal to 12.5. Then n will be equal to 11.25 divided by 2. 11.25 divided by 2. Calculate what is coming.
Sir, yeah, it's 11.5.
11 point, sorry, 11.5. by 2. Just calculate this one. 5.75. It is coming 5.75. Okay. So how many frequencies are present? Greatest integer function you have to take. Because frequency cannot be. So greatest integer function means 5. So it starts from 0 because fundamental starts from 0. So 0, 1, 2, 3, 4, 5. So how many? 6. And if you write this one 2n minus 1, then directly 6 will come. Because in that case, n equal to 1 will be fundamental. If you write 2n plus 1, then n equal to 0 corresponds to the fundamental. If you write 2n minus 1, then n equal to 1 corresponds to the fundamental. So in this case, you have to take the greatest integer function. Greatest integer function is box function, box x, box n. So that is the highest integer that is present. Because frequency cannot be in point. Number of harmonics cannot be a decimal value. It should be integer value. See, next question is not in the syllabus, that is Doppler effect. Next one, two thick dielectric slabs of dielectric constant K1 and K2, K1 is less than K2, are inserted between the plates of parallel plate capacitor as shown in the figure, the variation of the electric field. See, in the vacuum portions, electric field will remain same. Inside the dielectric, field is decreasing because of the dielectric constant K. So in the first part, it will be E by K, where E is the field in vacuum. In the second dielectric, it will be E by K2. Okay. Now K1 is smaller than K2, so field in first dielectric will be larger than field in second dielectric. But both are less than the field in the potential of the outer surface. That will be Q by 4 pi epsilon naught R. And since it is conducting sphere, so inside the conductor it will be 0. So option 2 is correct. Because since inside field is 0, potential inside is constant, and that is equal to the potential at the surface. Then question number 25. In a region of potential, the potential is represented by V as a function given, where V is in volt. Electric field you have to calculate. You have to first calculate through this that Ex equal to minus del V del x, that is the partial derivative. Ey equal to minus del V del y, and Ez equal to minus del V del z. So after finding the component, you have to put the value for 111 and calculate the magnitude of the field, and then the force on the test charge. Okay, so first we calculate this one, minus del V del x. So there is a minus sign, and after that 6x, its derivative will be 6, then minus 8xy. So it will be minus 8y, because when we are doing partial derivative with respect to x, other variables are taken as constant. So it will be minus 8y. Then other two terms does not contain x, so their derivative will be 0. Then similarly this one, minus of first term is 6x, so with respect to y derivative is 0. Second time y is present, so derivative is minus 8x. Next term y is present, so derivative is minus 8. Next term plus 6yz, so derivative is 6z. Next, with respect to z, first term 0, second term 0, third term 0, only the last term it is 6y. Then in the point which is required 1, 1, 1, means x equal to 1, y equal to 1, z equal to 1. So if you put y equal to 1, this will be minus 2, and there is another minus, it will be plus 2. This term, it will be minus 8, 6. Minus 8, minus 8, minus 16, minus 16 plus 6. That is minus 10. There is another minus. So it is plus 10. And this one will be minus 6. Okay. So now total electric field's magnitude at that point will be E equal to root over of Ex square plus Ey square plus Ez square, because we have already calculated the components, and these components are along the perpendicular axis. So E will be 2 square, that is 4 plus 100 plus 36, so it is root 140. Then this field is experienced by a point charge of magnitude 2 coulomb. So the force on the charge we know, F equal to QE. So Q is 2 and E is root over of 140. So it can be written as 35 into 4. So another 2 will come out. So it will be 4 root 35 Newton. Two cities are 150 km apart. Electric power is sent from one city to another city through copper wires. The fall of potential per kilometer is 8 volt. Okay, potential per kilometer falls 8 volt and the average resistance falls per kilometer is 0.5 ohm. The power loss in the wire. Okay. So potential per kilometer falls by 8 volt. Okay. So change in potential delta V, that is equal to 8 into 150. 8 volt per kilometer into kilometer. So that is the total change in the voltage or total change in the potential, that is 8 into 150, and total change in resistance per kilometer, that is delta R. Average resistance per kilometer, not delta. So resistance will become, it is 0.5 into 150. Okay. Because 0.5 ohm per kilometer is given, multiply it with kilometer, so you will get the total resistance. Then loss in power, delta P equal to delta V whole square by R. Calculate. This is in ohm, this is in volt. Substitute and calculate. So it will be 19.2 kilowatt. Next, the resistance of the two arms of a meter bridge are 5 ohm and R respectively. When the resistance R is shunted with an equal resistance, the new balance point is 1.6 L1. The resistance R is. So previously L1, now it will be, balance point will become 1.6 L1. So we can write that previously 5 by R, it will be L1 by 100 minus L1. This is my first equation. Now, this one is remain 5, but since it is shunted with another R, so equivalent resistance on that right arm will be R by 2. Now, balance point will be shifted. 100 minus 1.6 L1. So these are two equations. Eliminate L1 to find R. Okay. So this one will be actually R by 2, so it will be 10 by R. So from the first equation, you can write R by 5 equal to 100 minus L1 by L1, that is 100 by L1 minus 1. So R by 5 plus 1 equal to 100 by L1. This one will be your first equation after rearranging. From the second equation, you can write this one is coming 10 by R. So if you invert this one, say it will be R by 10 equal to 100 by 1.6 L1 minus 1. Okay. Then you can write this one as R by 10 equal to 100 by 1.6 L1. Now we already know that 100 by L1 is R by 5 plus 1. So it will be 1 by 1.6 into R by 5 plus 1. Now 1.6 can be written as 16 by 10. So I can write this one as 16. This is 10 and calculate. Otherwise, if you divide directly from 1 and 2, then first you will find L1, then you have to find R by putting the value of L1. So rearrange it first such that you can eliminate L1 directly to find R. R will be 15 ohm. So it will be 16R equal to 100 into R by 5. 100 into R by 5 is 100 by 5. That is 20R plus 100.
Minus that. Minus what? That minus one.
Which one?
No.
Then full substitute to look. See, up to this one, is it right? This one is R by 10. Oh, R by 10 plus 1. This one is R by 10 plus 1. This is equal to 100 1 by 16, 1.6 into 100 by L1. That is R by 5 plus 1. I missed that minus 1. So it is R by 10, this 1 is going on that side. So it will be R by 10 plus 1 equal to 1 by 1.6 into R by 5 plus 1. Then 1.6 means 16 by 10. So it will be 16, this one will be 10. Then just multiply. So it will be 5. 4. So it will be 4 into R by 10 plus 1 equal to 5 into R by 5 plus 1. 5 into R by 5 means 2. This one is 5, this one is 8. This one is 8, so it is 8. 8 into R by 10 plus 1 equal to 5 into R by 5 plus 1, that is R plus 5. So it will be 8R by 10, 8R by 10 means 4R by 5 plus 8 equal to R plus 5. So it will be 8 by 5, that is 8 minus 5, that is 3 equal to R minus 4R by 5, that is R by 5. So R equal to 15 ohm. Question number 29. Following figures show the magnet arrangement of bar magnets in different configuration. Each magnet has dipole moment M. Which configuration has highest net magnetic dipole moment? See, if the magnetic moment sum is calculated, then it is a vector sum. Then vector sum and M equal total or M resultant M will be root over of M square plus M square plus 2M1 M2, that means 2M square cos theta, but theta is the angle between them. Then we can write this one will be 2M, 2M, there is a 2M square, this is 2M square, so 2M square common into 1 plus cos theta, its square root, hence it is root over of 2 into M into, you can also convert this one to write in this format or in the normal format that you can also calculate. So this one you have to calculate. Okay. M square plus 2M square cos theta, its root. So it will be 2M square into 1 plus cos theta. Don't try to simplify this one, keep it in this form. Now, in the first case, theta is 90 degree. So this term will be 0. So magnetic moment will be root 2M. Next case, it is 0. because magnetic moments are directed from south to north, next one south to north in the opposite direction, so they will produce 0. Next one is 30 degree. 30 degree you can put the value of cos 30 and calculate, and another is 60, whichever is higher. Cos 30 is greater than cos 60, so for 30 the value will be the higher, because cos 30 is root 3 by 2, cos 60 is half, so cos 30 is higher, so magnetic moment is highest for configuration 3. Okay, then question number 30. If an ammeter 0.2% of main current passes through, in an ammeter 0.2% of main current passes through a galvanometer. If resistance of the galvanometer is S, then the resistance of the ammeter will be. See, ammeter means a galvanometer with a shunt resistance in parallel. So main current, suppose I, it is said that 0.2% of the main current passes through the galvanometer. Means 0.2 by 100 I, this current passes through the galvanometer. So the remaining current I minus 0.2 by 100 I, this passes through the shunt. Okay. This passes through the shunt. Then galvanometer resistance is given, so you have to find out S. So these are in parallel combination, so we can write that 0.2 I by 100 into G equal to I minus 0.2 I by 100 into S. From this, calculate S in terms of G. So this one will be, can write 2Ig by 1000. This one same. So I will multiply with 10 by 10. So it will be 2I by 1000. So it will be 1000 minus 2 means 998 I S by 1000. This 1000 cancels. I cancels. So S will be G2G by 998, that is G by 499. Okay. Then you have to calculate the resistance of the ammeter, RA, that is G into S by G plus S. G into S by G plus S. Means the equivalent resistance of G and S. That is the resistance of the ammeter. So in this way, divide numerator denominator both by S. Then it will be G by S plus 1. But G by S is 499, so it is G by 500. two identical long conducting wires AOB and COD. COD are placed at right angles to each other with one above the other as shown, such that O is their common point for the two. The wires carry current I1 and I2 respectively. Point P is lying at a distance O along the direction perpendicular to the plane containing the wires. The magnetic field at the point P that you have to calculate. Point P is lying at a distance d from O along the direction perpendicular to the plane containing the wires. Okay. Okay. See, if you consider this one, so we consider two wires. Say along x-axis is one wire carrying current I1, along y-axis is another wire carrying current I2. These are infinitely long wires, and from this is 90 degree, then these two wires are at an angle 90 degree. Not only that, these angles are also 90 degree. Okay. Then from this junction at a distance d, you have to find the field at this point. That point is E. Then, see, for I1, if I1 means actually coming out of the board. This is y direction, this is I consider to be the x direction, this is the y direction, this is the z direction. So I is actually coming out of the board. So since I is coming out of the board, at this point T, the field is directed like this, that means in the negative y direction. So I can write the vector field V1 equal to mu naught I at a distance d means 2 pi d. The direction is minus j cap. Okay, mu naught I by 2 I1 by 2 pi d minus j cap. Okay. Similarly, V2 for the second one. It is along this direction. So at this point P, this field is coming in this side. That means in the positive x direction. So I cap will be there. So it will be mu naught I2 by 2 pi d I cap. Okay. So you have to take their, calculate their magnitude, resultant magnitude. Calculate the magnitude of the resultant. That will be B equal to magnitude square sum into root. That will be mu naught I1 by 2 pi d x square plus mu naught I2 by 2 pi d x square, then root. That means mu naught come out, 2 pi d come out, will be root of I1 square plus I2 square. So option 4 is correct. see, for the next one, you have to simply use the formula of motional EMF. And in the case of motional EMF, length of the two extreme point is taken as L, not the entire length of the cord. Okay, so total length of the wire is pi r, but that is not the length for calculation of the motional EMF. Motional EMF means two extreme points distance, that is 2r. So E will be VLB. So V into 12 2r into B. That means B. That is 2RBB. That is the EMF developed. And only one option is there with this. So option 4 is correct. Now,
Why is it highest potential and R, sir?
R is
Highest potential.
highest potential. Okay, see. For this question, since first part is the only answer, then we can easily say that 4 is the correct option. But if someone asks that how R is at high potential, let us consider when the wire is falling through the magnetic field. Like this, magnetic field cross, encircle, cross in this region. Okay. So magnetic field is inside the board. Wire is falling like this, so it has a velocity in this direction. So any electron in the wire, suppose here, electron. Okay. So what will be the, if force on this, what is the magnetic force on this? That we want to calculate. Charge particle moving in this direction with velocity v, magnetic field v. So E cross B. So QE into Q into V cross B. So Q V cross B. E is downward, B is inward. So the force is on this side, but since this is an electron, the force will be on this side. For the positive charge, the force will be on this side, V cross B. But since it is electron, Q is minus E, so the force will be on that side. So electrons will accumulate near this region. So positive charges will accumulate. So this side is at higher potential. So R is higher potential. Three terminals are given. This is P, this is point Q given, this is R. Since positive charges are accumulated on this side, electrons, free electrons are moving on this side. So positive charges are accumulated on the other side. So this is high potential, and this is. Now tell me, if I join a resistance between these 2 points, in which direction current will flow? Through this way. Now the circuit is complete. Then in which direction current will flow? Through the PQR junct path. What will be the direction of current from PQ, current through PQR?
R to P, sir, from the resistance.
How? Why?
Because electron is flowing from this side.
Electron is flowing
From Q to P, sir.
Q to
P.
P. So in this direction, ambit is along this or along this? That I require.
For the electron, sir.
For current
That side.
from P to
Q.
P to Q, then through R. That is because that is the portion inside the cell. Inside the cell, current goes from low potential to high potential. That's why it is termed as motional EMF. When you add the external circuit, then electron will, in the external circuit, current will flow from high potential to low. But since this is motional EMF, this is the internal circuit. In the internal circuit, current will flow from low to high potential. So whenever this type of question comes, first put a resistance to complete the circuit, then only answer. Because otherwise many students write that, oh, this is potential, this is, there is no line, this is high potential, this is low potential, current will go along this. A transformer having efficiency 90% is working on 200 volt 3 kilowatt power supply. If the current in the secondary coil is 6 ampere, the voltage across the secondary coil and the current in the primary coil respectively are. That you have to find out. See, P1 is given, primary coil, it is 3 kilowatt, means 3000 watt. P2 working with 90% efficiency, so it is 90 by 100 into P1. So it will be 2700 watt. Now in transformer, we can write that P2 by P1, that is equal, 2 is the secondary coil, 1 is the primary coil. So it will be V1 I1, sorry, V2 I2 by V1 I1. Okay. V2 I2 by V1 I1. Just put the values. P2 is 2700, P1 is 3000. Now, V1 is given, V1 is 200. Okay, this one. So first we have to calculate the voltage across the secondary coil. And the current in the primary coil. Oh, I2 is given. I2 is 6 ampere. So P2 is there and another is I1. The secondary coil and current in the primary coil. So from this we can also write this one, that P2 equal to, P2 means 2700 equal to V2 into 6. So from this we can calculate V2 first. So V2 is coming 2700 by 6. 3 450, and then substitute this value there to find I1. Okay. We already calculated the power in the secondary from the efficiency, that is 2700 watt. So that equal to V2 into I2. I2 is already given in the problem, that is 6 ampere. So from that I can calculate V2 and then substitute that V2 there to find I1. So I1 will be 15 ampere. Or you can directly find after this calculation. 3000 equal to 200 into I. It will be 50. Now 34. The light with an energy flux 25 into 10 to the power 4 watt per meter square falls on a perfectly reflecting surface. At the normal incidence, if the surface area is 15 cm per second square, the average force exerted on the surface is. Okay. Then F into V, since light is falling, we can write F into C, that is the power. So power equal to energy flux suppose I in meter square into area. Area means A but light is striking and then going back, means there is a total change in momentum, due to that force generates. So it will be 2 times. So we can calculate from this that force F equal to 2IA by T and calculate. I is given 25 into 10 to the power 4. And remember, area is given in centimeter square, so you have to convert the average force. Because light with a velocity c strikes and then reflects, so there is a change in momentum 2 times. Into area 25 and 10 to the power 4. Okay, into area is given 15 centimeter square, means 15 into 10 to the power minus 4 divided by c, means 3 into 10 to the power 8. into 10 to the power 4 minus 4, these two cancels, so it will be 10 by 10 to the power 8 means 10 to the power minus 7. Into, if I divide this one, so we have to multiply here with another 10. Okay, so 2.5 into 10 to the power minus 6 Newton. Next, you have to only find the width of the central bright fringe. Distance between two dark fringe means width of the central bright fringe. Distance between the two first order dark on both sides means the width of the central bright. So how can we find that? We know that A sin theta equal to n lambda. So since these are first order dark fringe, I put n equal to 1. So since these are very small, then sin theta almost equal to theta. So theta equal to coming lambda by 5 by 4 and by 2 0. root আসছে কেন ক্যালকুলেশন wait let the path difference lambda which is k
Sir,
but
let's solve it once
square intensity equal to amplitude square. I usually applied one more rule. This rule is not there. Additional root I have applied. So that's why all this problem. Okay, intensity equal to amplitude square, so it will be a1 square plus a2 square plus 2a1 a2 cos delta. I have written the formula for amplitude and write that intensity. So it will be 4a0 square and this one will be 2a0 square. Because cos 2 pi is 1, so it will be 4a0 square, this one will be 0, so it will be 2a0 square. So k prime by k, that is coming 1 by 2. So k prime equal to k by 2. Next one, if the focal length of the objective lens is increased, then magnifying power of the microscope. See, for microscope magnifying power is L into D by FO into FE, and for telescope magnifying power is FO by FE. Okay, so focal length of the objective lens is increased. So in the first case, if FO is increased, then M1 will decrease. And in the second case, M2 will increase. So option 4 is correct. In the first case, it is inversely proportional. Second case, it is directly proportional. 38. The angle of prism is capital A. One of its reflecting surface is silvered. Light rays falling at an angle of incidence 2A on the first surface returns back to the same path after suffering reflection at the silvered surface. The refractive index mu of the prism. This angle A, this is silver. Angle of incidence 2A. This one, light enters to this, reflecting back means this angle 90. So this angle is 90 minus A. So angle of refraction R1 is A again. Then we can apply Snell's law that sin I1, that is 2A, by sin R, that is A, equal to mu. So it will be 2 sin A cos A by sin equal to mu refractive index equal to 2 cos A. Option 2. When the energy of an incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from the metal surface increased from 0.5 electron volt to 8 electron volt, the work function of the metal. This one is given kinetic energy in the first case, say K1, so that is equal to, first one is energy of the incident radiation E minus work function. In the second time K2, that is increased by 20%. Increased by 20% means it will be E plus 20 E by 100 minus W. Okay. Then we can write K2 equal to this one, that is 120 E by 100. 120 E by 100 means 6 by 5 E minus W. Then from this eliminate E to find W. So we can write from this that K2 minus W, K2 plus W equal to 6 by 5 into E. That E is K1 plus W. So I will substitute. Okay. Then it will be 5K2 plus 5W equal to 6K1 plus 6W. So 5W minus this one, so that is W equal to 5K2 minus 6K1. K2 is given 0.8. So 0.8 into 5. 4 and 6 into 5, 3. electron volt. K2 is given 0.8 electron volt, K1 is given 0.5 electron volt. So it is 4 minus 3, that is 1 electron volt. If the kinetic energy of a particle is increased 16 times its previous value of the percentage the percentage change in de Broglie wavelength. See, initially de Broglie wavelength lambda equal to h by p, that is root over of 2m into e. Then it will be some lambda prime, that is 1 by root over of 2m e prime. Okay, so lambda prime by lambda, that is coming root over of e by e prime, root over of e by e prime, lambda prime by lambda. Now, previously the kinetic energy is E, now kinetic energy is 16 times of its previous value. So lambda prime by lambda equal to E by 16E. So it will be 1 by 4. Now subtract 1 from both sides. Lambda prime by lambda minus 1 equal to 1 by 4 minus 1. So it will be lambda prime minus lambda by lambda equal to 1 minus 4 by 4. Now multiply both sides with 100. So it will be minus 3 by 4, that is minus 75%. So the answer is 75% because it is decreased. So if kinetic energy is increased, then wavelength will be decreased by 75%. Hydrogen atom in ground state is excited by a monochromatic radiation of lambda is given number of the spectral lines. You have to calculate the principal quantum number of the orbit in which it will go. Okay. First calculate that n in which it will rise. In which orbit the electron will jump if it is excited with this energy. That you have to calculate. First calculate this one using this form. That what will be the energy given, that is hc by lambda, convert it to electron volt.
12.8.
12.8. 12.8 electron volt. Volt. So it is going to which excited state? Fourth excited state it will go. So it will go to the fourth excited state. Fourth excited state means n equal to 4. So how many spectral lines formed? Since n equal to 4, the spectral line forms will be n into n minus 1 by 2. That is 4 into e by 2, that is 6 spectral lines will be formed. Because you can equate this one with energy of the hydrogen atom minus 3.4 by n square electron volt is 12.8 eV. So this minus is only for the sign, that is attractive. So no need to take this minus. Then you can find the value of n, and from that you can calculate. You can directly use that de Broglie that 1 by lambda equal to 1 by n1 square minus n2 square, that relation also we can use. Okay. Or otherwise, after calculating n equal to 4, you can also draw this line to find. That is n equal to 4, 3, 2, n equal to 1. From 4 it can go to 3, from 4 it can go to 2, from 4 it can go to 1, from 3 it can go to 2, it can go to 1, from 2 1. So how many spectral lines? 6 spectral lines. Binding energy per nucleon of lithium and helium nuclei 5.6 and 7.6 MeV respectively in a reaction, that is given the Q value. See, in this question you have to calculate the binding energy of the lithium minus binding energy of the helium. Then it will be the Q value that you will get. So, binding energy of lithium minus binding energy of helium. Okay. That will give you the answer. But there is a logical mistake in the question. See, if you take the binding energy of lithium, how many nucleons are in the lithium? 7. So it will be 7 into that binding energy is given 5.6. So may I write the details? 7 into 5.6, this is a minus, plus this one. there is 2 helium ion, 4 nucleons are there and 2 helium ions are produced. So 2 into 4 into 7.06. This one will give you the Q value. Okay. This one will give you the Q value. The logical question is that why you consider the binding energy of the hydrogen to be 0? They considered that 1H1, since there is only one proton, there is no neutron, so there is no binding energy. But in the binding energy versus number of nucleon curve, mass number curve, is the binding energy ever be 0 for hydrogen? The curve is like this. So for hydrogen, helium belonging from this region and uranium and all this belonging from this region belongs to iron. So it is not 0. Though they considered in this problem that since there is no other, only one particle, only one proton, so it is 0. 43, now not in the syllabus. 44. This is given for a solar cell. We are given a solar cell where point A represents open circuit voltage. Point A means open circuit voltage because current is 0 in the open circuit, so it is the open circuit voltage. Point B represents short circuit current, means voltage 0, still there is a current in the opposite direction, so it is short circuit current.